Hello everyone, hope everyone is doing well. Today we're going to learn how to interpret coefficients when the variables are in different formats. So we will look at what we would call a linear level like this, where the power on education is just 1. We are going to look at variables that repeat themselves, like experience here. So we have experience to the power 1 and then experience squared, and we will see how that affects the dependent variable. We will see how a variable that is what we would call a dummy variable affects the outcome. And finally, we're going to look at another variable, which is just in terms of unit, like dollars, or other units may be length or breadth or height. Now, we're looking at this generic equation where we are studying how an individual's income here, we are measuring it in dollars, how this is affecting education. Now, education we are going to measure in years of education. Experience, both of them are again measured in years. Urban is what we would call a 0, 1, a dummy variable. 0 meaning no, the person's not in an urban area. 1 means yes, the person lives in an urban area. And finally, we have what we would call parents' income. So this individual's income, we want to see if parents' income affects the individual's later income. And this one is also in dollars, and this is our shock, or what we would call a residual. Now let's look at the first example. Let's look at how do we take the derivative of income with respect to education. So in our case, we are going to do a partial derivative because here we have different variables in. So we are going to look at small delta income, d income over d education. That comes just here, and it's a linear variable. So we are going to just add it to be beta. So we can just write it out just like that, saying that as education increases by 1 year, so as my education goes up by 1 year, my income goes up by beta dollars. So that was pretty simple. If we have a linear equation like that, we can easily take the derivative of that. Same goes with something like parents' income. So here, if I take the derivative of income with respect to parents' income, I get mu. So here too, our interpretation is pretty simple. It's just like how we did it with education. Next, we are going to look at dummy variables. Now, a dummy variable like urban only takes 2 values, so we cannot really use derivative to find the effect of urban on income. What we will do here is just say hold everything constant and take 2 individuals, one with urban equals 0, the other is urban equal 1. Now, if that's the case, then if everything else is the same, then what we will do is we are going to subtract income when urban equal 1 minus income when urban equal 0. And that, if everything is constant and I subtract urban 1's income from urban 0, I end up with the coefficient of urban, which is going to be lambda. And the way we would interpret this is, and so we would say a person living in an urban area earns lambda dollars more or less, if it's a negative value, we would say net less, than a person living in a rural area. Now finally, we have experience, which is what we would see in this case. So we have the squared terms, so experience. So we have to see how many times does experience appear in this equation, and we have it 1 time here and another time here. So when we take the derivative of income with respect to experience, we have to take into account both experience and experience squared. So if I do that, I get, so my derivative is going to be gamma 1 plus 2 gamma 2 of experience. Now why 2 gamma 2? Well, since experience squared has a 2 here, so when I take the derivative of that, I get 2 gamma 2 experience of the person. So we get this number here. Now, how do we interpret it? The other ones were pretty simple to interpret because we already had the coefficient and its form. Here, we actually have the variable too, and it gets a little difficult to interpret this number. So what we will do here is we will say we will assign a value to the experience. It could be any number. So I could say let experience be equal to 5. So let's say that experience equals 5. So I have 5 years of experience. So our derivative then becomes gamma 1 plus 10 gamma 2. So it is now our derivative has become gamma 1 plus 10 gamma 2, which is now a little easier to interpret. And that would be our interpretation. If experience increases from 5 to 6 years, then income goes up by gamma 1 plus 10 gamma 2. Now, if we actually had numbers for these cases, so let's say we have these numbers. We don't need numbers for alpha and any other cases. So now, instead of delta income over delta I, delta income over delta educ becoming beta, now my number is 50. So I would say if education increases by 1 year, then my income goes up by $50. Same thing with parents' income. Instead of mu, now I have a number, so I'll say it is 5. So if my parents' income goes up by $1, my income goes up by, we would say here, $5. With urban now, if everything is constant, so basically saying all the variables are constant, we can say now this value is going to be 200. So a person living in an urban area then therefore earns $200 more than a person living in a rural area. And finally, we said that we have our gamma 1 is 2 and gamma 2 is 3. So if that's the case, then I'll say this number is going to be, so the coefficients are in red, so 2 plus 2 times 3 experience, which would then equal to 2 plus 6 experience. So now if I say experience is 5, and now if my derivative is 2 plus, if my derivative is that, then I would say it is going to equal to, at 5, the impact of experience on income is 32. So I would say if my experience goes up from 5 to 6 years, income will go up by $32. Now this seems easier. Now let's look at a case where we have natural log. The thing about natural log is if I take the derivative of natural logs, it is the derivative, let's say we have a number, y equals ln of x. In that case, if I were to take the derivative, dy over dx would be equal to 1 over x. Now, if I multiply dx on both sides, then these dx get canceled, and what I have eventually is going to be dy equals 1 over x dot dx. Now, this is something interesting here. This value dy is basically just telling us this is the change in y. On the other hand, dx is also giving us change in x, but it is divided by an x down here. So if you remember from before, if I have dx over x, which is basically change in x over x, this kind of looks like a percentage formula. So if I have this form, and now I can say dy equals to 1 over x dot dx times, if I then multiply and divide the same side by 100, I can then combine all this part and make it into a percent form. So then it will be dy then equals change in a percent form of x times 100. So 1 over 100, then percent change in x. So it's a nice way of interpreting x not in dollar forms or changes of x in dollar form, but in percent. And we use this if we have very big numbers like income or GDP, then it's easier to see how a 1% change, if I say my income goes up by $1, it really doesn't make any difference. $1 does not have much of an effect. If I'm earning $40,000 and now I earn $40,001, the effect on other factors would be very low. But if I say my income went up by 1%, now that's a bigger amount, and I can see how that impacts other factors. Now with that, let's look at how we would take the derivative of income with respect to education. So we would write the ln of income over delta education. Now that would equal to beta. That we know for sure. We haven't really changed anything here. Now ln of income does not really help us. So another thing we need to know is if I have ln of y equal x, then d ln of y over dx equals to 1, or a number. Now this part, we can break it up into 1 over y dot dy over dx equals 1. So in that case, if I have this form, I can now say everything else remains the same, so I can write 1 over income dot d, or delta of income, over delta education equals beta. With that, now I can multiply delta of education on both sides to get rid of it. So I can write the next line as delta income of I divided by income of I equals beta of delta education. So this is, again, we're talking about, this is change in education, and this is the percentage change in income. Now to make it a full percent, we now need to multiply by 100. So if I multiply this side by 100, I would also need to multiply the right-hand side by 100 too, or divide the left-hand side by 100. Let's just multiply the right-hand side by 100, and we can see that income is in percent form now, and my education is in change. So what I would say that is, an easier way to interpret it is, the percentage change in income equals beta times 100 dot delta education. So we would say that if education goes up by 1 year, then income goes up by beta times 100%. So that gets easier to interpret. Now let's look at when both sides have natural logs. If both sides have natural logs, that makes it a little easier. If I have ln of y equals to ln of x, let's put a value here, let's say 2 ln of x, then if I take the derivative of this, it would be delta y times over delta x. We would have a 1 over y in front equals 2 times 1 over x. Now if I multiply delta x on both sides, then I get, this side will get cancelled. So then I'll have 1 over y of delta y equals 2 times 1 over x dot delta x. Now both sides have that same shape, change in y over y, change in x over x. Now if I multiply both sides by 100, then I get percents. So then this becomes percent change in y, and this side becomes percent change in x. Thus, if I take that derivative here, where I have mu, ln of parent income, so I would say it would be delta ln income. So if I then solve it out, it should be equal to, so thus we have this, we have on this side, this is going to be my percentage change in income, and on this side we have percentage change of parents' income. So we would say if parents' income increases by 1%, income of the individual will increase by mu percent, whatever mu is. We don't have to multiply or divide the coefficient by hundreds like we had to do with education. If my dependent variable is in logs, but my regressor or independent variable is in linear form, we have to multiply the coefficient by 100 to get the effect. If both my independent and dependent variables are in log form, then we don't have to multiply by 100. Next, let's look at the urban variable. Since we said the urban variable is not, we cannot take derivatives of that, so let's just assume that everything else is the same, except that, so all variables are same. So if one person lives in urban, the other person lives in rural, how would that affect everything? So we would say then income of, let's say, the urban person minus income of the rural person. So income of the urban person, everything else would be the same. So alpha plus beta education plus gamma 1 experience plus gamma 2 experience square plus lambda dot urban. Urban we said is 1 plus mu of parents' income. And we are even saying that the other shocks are the same. Now we are subtracting that from alpha plus beta education plus gamma 1 experience I. So everything is subtracted for the rural person. And if you notice, the urban person, the coefficient lambda is multiplied by 1. For the rural person, the coefficient is multiplied by 0. Now, if we subtract their two equations, we will see that everything else gets canceled, since everything else is equal except for the lambdas. So we end up with lambda minus lambda times 0, which is basically 0. So we end up with lambda. So now we have, now remember here, it was income of urban minus rural. This was before. Now we have a natural log. So from here we can see that ln of income of urban minus ln of income of rural equals lambda. One thing we know about natural logs is ln of, let's say, a minus ln of b. This will equal to ln of a over. So we can write this as ln of income of urban, income of rural equals lambda. Now, if that's the case, we can then, if we then raise both sides to, then e and ln get canceled out. So we are left with income of urban over income of rural equal to e to the lambda. Now, if I were to find the percentage change of there, or the percentage here instead of change, it would be the percentage difference. Let me subtract both sides by minus 1. If that's the case, then I can see if I solve it out, it will be income of urban minus income of rural divided by income of rural equals that value. Now, if I multiply both sides by 100, and this is the formula. So we have to e to the raised to the power lambda minus 1 times 100. So we get our interpretation is, this value is now, how much more is urban income than rural income in percentage form. Let's say that a person living in an urban area earns e to the lambda, e to the power lambda minus 1 times 100% more income or less income than a person living in a rural area. Now, finally, we have our form of with quadratic equation. So this shape will be very similar to what we have done with the case of education. So what we will have here is, we would do 1 over income, delta income, times 100 equals times delta experience times 100. So now this is what we will have. This side is going to be my change in percentage change in income, and this is just going to be the change in experience. We would have to fix experience to a certain value. We would say let experience equals to, let's say, 3. Then, so this is our form right now. We have it in this form, and now we can see that if I have a certain value of experience, then this value will become 3, because I have experience here, but not delta experience. But delta experience doesn't change. Delta experience is just change in experience. So this will become 3. So that means I'll get delta 1 plus 6, delta 2 times 100. Now I will say, if experience increases from 3 to 4, which means now this one is increasing by 1 year. If I said experience increases from 3 to 6, then that would be delta experience would be 3 years. If I said experience would go from 3 to 10, then delta experience would be 7 years. Since it's going up by 1 year, so delta experience here is going to be 1, then we will say income increases by much percent. So delta 1 plus 6, delta 2%. Now let's look at numbers, because it does get a little interesting when we look at numbers. Let's say we have these numbers. So then if beta equals 0.12, we will see that this beta is now going to be 0.12. So then if I were to multiply it, I would see that my value would go up to 12%. So if education goes up by 1 year, then my income should go up by 12%. In the next case, if I have mu equals 3, then I don't need to change anything. I would just say mu. Parent's income goes up by 1%, income of that individual will go up by 3%. Next, we have our case of lambda. Now, in this case, lambda we said was 0.2. In this case, we said the coefficient of lambda, as in the example, was 0.2. So we're going to put 0.2 here. And when we solve this out, we get our effect of to be equal to 22.14%, which means that a person living in an urban area earns 22.14% more than a person living in a rural area. We said gamma 1 is going to be 0.12 and gamma 2 is going to be, or gamma 1 is going to be 0.2 and gamma 2 is 0.6. Now plugging in gamma 1 equals 0.2 and gamma 2 equals 0.6, we get this big number, 380 times delta EXP. So now if we say that if the experience goes up from 3 to 4, then our income should go up by 380%. So it's a big number, big increase, but that's because our coefficients were pretty big. The last thing we will do is what if income is in regular form? So we have income of I, which is just the regular income. Now, and how do we take the derivative of something that's in this form, but parent's income is in natural log? So what if I have something that is in the form of y equals ln of x? Now, if I take the derivative of that, it would be delta y over delta x, or dy over dx, since we have just two variables. That should be 1 over x. Now, in this case, it should be delta y equals to, if I multiply delta x on both sides, then I get 1 over x times delta x, and the other delta x goes away. Now I need to convert this to percent, I need to multiply it by 100. And to keep it simply, I can either multiply the left-hand side by 100, or I can just divide by 100. So in this case, as you can see, if I have income I equals alpha plus and all the other variables, and finally I have mu dot parent income, and this is in ln, then if I take the derivative of that, this delta income over delta parent income, it's going to equal to mu times 1 over the parent income. Now, as we said, we can multiply both sides by delta parent income, and then that way the left-hand side gets canceled out, and we are left with equals mu times. Now, to convert this side to a percent, I need to multiply it by 100. So if I multiply this by 100, it becomes a percent, but I need to then divide it by 100 or multiply on the left-hand side by 100 to keep it balanced. So what I can do is I can divide the mu by 100. Then all this that I have, this becomes percentage change in parent's income. So if I were to write it out, it would be if, and here we have it, if parent's income increases by 1%, because this change in parent's income, we have it here as 1%. But income here, as we notice, it's not in percent, it's just in change form. So we will say individual income increases by the coefficient over 100, mu over $100. Now, in our example above, we said mu was equal to 3. So in that case, we would say that if parent's income increases by 1%, individual income would increase by 3 over $100, or $0.03. Hopefully this was helpful, and I will see you at a later video. Have a good day. Goodbye.